Okay, in this video, we will continue, okay, on how we the basics of discrete event simulation and how discrete event simulation is being conducted. Okay. Here, what I will introduce to you is the event scheduling or the time advance algorithm. Okay, which is the algorithm lah behind the discrete event simulation. So basically, in conducting discrete event simulation, we will use a simulation table. Okay, simulation table to record the successive system snapshot at as time advance. So previously, the simulation table that we have seen in the Excel spreadsheet, um, that one is for simple system. Okay, once your system become more complex, okay, we need more information to it. So what we will see is the common type of simulation table used, okay, for running discrete event simulation. Okay, even for this demonstration, it is still a simple simulation table. Okay, uh, to the that I used to show to you. Okay, because the simulation table can get more complex than what we will see next. Okay, so basically in this in the simulation, okay, the sequence of action that a simulator must perform, okay, to advance the clock. Remember that this event simulation occur, okay, it's like taking a snapshot, okay, over time, right? So as the simulator advance the clock, okay, and build a new system snapshot, that event is called event scheduling or time advance algorithm. Okay, that's the mechanism we use, okay, to proceed in time. Okay, all right. So basically, this mechanism, okay, for advancing the simulation time and guaranteeing that all events occur in correct chronological order is actually based on the future event list. So I will show you the future event list, how the future event list will looks like. Okay, which is contains the event notice. Okay, for events that have been scheduled to occur at future time. Okay. All right. So we will see lah once an activity begins. Okay, what are the values being computed? Okay, and how are those components being affected? Okay, we will see that. Okay, this is a summary of the algorithm. Okay, so basically the main thing is you have to have a future event list. Okay, future event. Oops, sorry. Okay, future event list here. Oh, sorry, I forgot to on the pen. Okay, future event list here, okay? And then step by step you will advance the clock, okay? You will advance the clock to imminent event time, okay? So meaning that you will advance the clock to the next event, okay? That will occur at specific point in time. Okay, so then you execute the event, okay, and update all the system state, okay, the entity attributes and the set membership involved. Okay, and then you're gonna generate future event, a new future events, okay, and place that event notices in future event list. Okay, so you will rank these notices by event time. It will be ordered by time of occurrence. Okay, and then you're gonna update the statistic and counters that you are interested to know. Okay, so this is an example. Checkout counter simulation. Imagine we have a grocery store with one checkout system. Okay, meaning that one cashier and there will be a queue where the customer will that arrive will go into. Okay, so the main component is the waiting line. Okay, and the the checkout counter. Okay, so let's say the simulation analyst desire to estimate mean Estimate what? The mean response time. Okay, what is response time here? Okay. Desires to estimate the mean response time and also the mean proportion of customers who spend 5 or more minutes in the system. Meaning that there are two things that we want to know. Okay, the average response time and also the average proportion of time. Okay, the customer has to spend more than 5 minutes. Okay, so what is the response time? Response time is the length of time customers spend in the system. Maksudnya we want to know the average time a customer spend at the checkout counter. Meaning that the time the customer wait in the queue and the time the customer being served by the cashier. Okay, so that's why it's called system. System include the queue and also the server. Okay. Okay, this is, you can ignore this one. To be able to compute an individual customer's response time when that customer departs, it will be necessary to know that customer's arrival time. Okay, so we need to know the customer arrival time, and therefore a customer entity with arrival time as an attribute will be added to the list of the model component. Okay. Okay. For example, actually kalau from this is actually example taken from a textbook. Example 3 in the textbook. Okay, you can check the textbook for more detail. Okay. This customer and this customer entities will be stored in a list to be called checkout line. So kita akan ada list list called a checkout line. So ini adalah list that contains all the customers in that checkout line. Okay. Checkout line ni means the line for the customer to wait lah. Okay. Ni. So the customer will be labeled as C1 for customer 1, C2 for customer 2, C3 for customer 3 and so on. Okay, event notice. Okay, event notice on the future event list will be expanded to indicate which customer is affected. So we will see. Later we will go through an example. Ni for example, this is the event notice. This is an example of event notice. What does this mean? Kita akan tengok what this representation means here. Okay, it means that customer 1, C1 here, customer 1 will depart, okay, at time 4. D ni to represent departure. Okay, 4 ni the time lah, the time of the departure. This is an example of event notice. We use a symbol to represent the event. Okay, so event notice ni basically it will tells you what's going to happen in the future. And this event notice will be in the list, which is we call future event list, a list of future events. Alright, so this is before we go through that example, you need to know lah first this term the LQT and LST. So this is the number. L ni means it refers to the number the number of customer in waiting line, in queue. Q represent queue. So number of customer in queue or waiting line at time T. Okay. And LS ni the number of customer. S is to represent the number of customer being served. Okay. A number of customer being served at time T. Okay. So A, this is event. Event is arrival, departure, and stopping event. Meaning that maybe the end of the simulation. Okay. This is E ni represent end of simulation. Okay, the time when the simulation end. Okay, so arrival we represent with A, departure will represent it with D. Okay, so in this simulation we will simulate for 60 minutes. 60 minutes. Okay, event notice. This is an example of event notice. Okay, we represent the event notice by letter A, comma T. Meaning that this is arrival at time T. Okay. This one D and T represent departure, customer departure of the customer at time T, and this is a simulation stop time at time 60. Okay, activities we're gonna have the inter-arrival time and also the service time. Okay, delay will be the customer times spent in waiting line or waiting in the queue. Okay, entities. So this one, so the entities will be the customer, right? So we can represent CI to represent customer lah. Kalau si customer number 1, we call it C1. Customer number 2, we call it C2. So CI dot comma T. Customer 1 who arrive is customer I who arrive at time T. Okay. This is the way we represent the entities. Okay. Kita akan assign T, meaning the arrival time of that customer here. So for example, if we have C1 1, for example, meaning that this customer 1 arrived in the system at time 1. We use this to represent the entity of customer 1. Okay, event notice. This is event notice, the occurrence in the system kan, that will change the system state. Okay, so A, comma T and CI, meaning that this is arrival, okay, at time T of customer I. So kalau you ada A, contohnya A4 and C2 for example, right? So you mean that customer 2 arrive at time 4. Okay, for D, comma T, CJ, the departure of customer CJ at future time T. So for example, if you have D 5 C1 for example, oops. Okay. Kenapa ni? Okay. Masalah lah saya punya ni. Kenapa tak boleh klik ni? Okay, C berapa tadi? C1 Okay. So this means that the departure of customer 1 at time 5. Okay. This is a notice that will tells you what's going to happen in that future time. Okay. Set. Okay. Set is the normally a list lah, a list. Okay. For example, we have a checkout line. That means that it's gonna have the set of all customers, okay, at the checkout counter. Meaning that this is checkout line ni. Okay, we use checkout line. We name the set as checkout line to represent number of customers being served and also waiting to be served. Okay, and we're gonna order that by time of arrival for that customer. Okay. Okay, this is the statistic that we are going to collect. Okay. Remember that our objective is we want to measure the average customer spend in the system and also the average number of customer that need to spend more than 5 minutes, right? Okay, so these are the statistic lah that will help us, okay, calculate what we want to know. Okay, which is first, S is the sum of customer time spent in the system for all customers who have departed by the current time. Okay, so to know the sum, first we need to calculate the response time lah, meaning that the time customer spend in the system. How do we know the customers? How do we calculate the time a customer spend in the system? Okay, so the formula is the clock time minus the time of arrival. Okay. Basically, the clock time is the time at the departure time for that customer, okay? Minus the time of arrival, okay? So we will use this formula to calculate the S ni, sum of customer time spent in the system, okay? And ND is the total number of departures up to the current simulation time. F is the total number of customers who spend 5 or more minutes at the checkout counter. Okay, this is This is the simulation table, okay, used uh, to show the simulation, okay, of the checkout counter lah, okay, the checkout system, eh. So here, what we have here now is the clock. The clock is the represent the time, okay, the snapshot that we are taking of our current of our checkout system, okay. So and then we have the system state. Ni number of customer in the queue, okay, number of customer being served at the number of customer being served. Saya tengok balik LS ni apa? Number the number being served. Okay, LS 0 or 1. Okay, it only takes value of 0 or 1. Okay. So LS can be only 0 or 1. Kalau 1 maknanya ada customer being served. 0 mean there is no customer being served at that time. Okay, at this particular clock time. Okay, and then we have the checkout line. Remember, this is a set, a set, meaning it shows the customers at the checkout line, okay, at the server and also in the waiting line, and it's order in the according to the arrival time. Okay, this is the future event list. Okay, future event list, it contains the event notice, list of event notice. This is event notice. Okay, future, there are several event notice, meaning that event that will occur in the future. And then this is the cumulative statistics. So how do we fill out this table? Okay, so let's say we have the inter-arrival time of the customers here. Okay, service time also here. Okay, these values, these values can be, for example, if you set the inter-arrival time to be randomly generated, so you can, meaning that you can sample the inter-arrival time, okay, from using random number generator tu. Okay, let's say this is already given lah, okay, for all the customers, inter-arrival time and also the service time. Okay, so based on the inter-arrival times and service time generated, okay, or specify, kalau you specify yourself, let's say the service time is constant ataupun it depends on the type of the customer. So you can specify lah, okay, what will be the value here. Alright. So based on this, inter-arrival time and service time, how do we fill up this table? Okay, we start at clock time 0 lah. Okay, that is the starting point. At clock time 0, normally we gonna have the first customer arrive. Okay, so at this point there will be no customer in the queue because at time 0, when the customer arrive at the cash counter, it will directly go to the server, right? So there will be one customer, okay, in the server, okay, being served. Okay, so the checkout line, at this point only customer 1, okay, which arrive at time 0. Customer 1 that arrive at time 0. Okay, what will be the future event list after time 0 ni? What's gonna happen next? Okay, so we will have, okay, the next event is we're gonna have the arrival of customer 2, arrival of customer 2 at time 1. That's the nearest future event of arrival lah. So basically in future event list ni, we're gonna have a list of arrival, next arrival, a list of next departure, and also the end time of the simulation. Okay, there are 3 things lah we're gonna have in the list. Okay, so arrival, who will be arrive next? Customer 2. At what time? Time 1. Okay, about departure, who will depart next? Okay, customer 1. Right now we only have customer 1. So this customer 1 will depart at time 4 because of the service time is 4 minutes, right? Okay. So currently all the statistics still remain 0 lah. Okay. Now at time, okay, how do we advance to the next step? Okay. So remember that in the ES, Okay, we only advance to the next step at discrete point in time. So the next step will be based on this future event list. Okay, so kita akan tengok which event, based on event notice here, which event that will occur first among these three event notice. Okay, which will occur first? Of course lah, the arrival of customer 1, right? Which is at time 1. Okay, so we will gonna advance to the next time 1. Okay, at time 1, we're gonna have arrival of customer 2. So what happened is customer 2 arrive, so it will go into queue. So that's why we're gonna update the system state. Okay, there will be one customer in the queue. Okay, this is customer 2. Customer 2 will go into the queue. And at this point, the server is still serving the customer 1. Okay, so server is still serving a customer. Okay. How do we know that? Because we know customer 1 only depart at time 4. So meaning that at time 1 it's still being served. Okay, so at the checkout line, who are at the checkout line? So at this point, only customer 1 who arrive at time 0 and also customer 2 who arrive at time 1. Okay. So now we're going to update the future event list. What will happen next? Okay. For arrival, departure, okay, what will happen? Okay, for arrival, who will arrive next? Of course, customer 3. Okay, customer 3, how do we know when will customer 3 arrive? It's based on this inter-arrival time here. Okay, so here number 1 means the inter-arrival time between customer 1 and customer 2, okay, is 1 minute. Inter-arrival time between customer 1 and customer 3 is 1. Okay, it's still 1. So 3 between 2 and 3 is 1 minute. Okay, for customer 3, inter-arrival time is 6, meaning that between 3 and 4, customer 3 and customer 4, the inter-arrival is 6 minutes. Okay, macam tu. So we know that customer 3 gonna arrive, okay, 1 minute later. Okay, so the next arrival is customer 3. So 1 minute later mean at time 2 lah. Okay, at time 2, 1 minute later. So because we are currently at time 1 kan, 1 minute later is at time 2. Okay, so we update the arrival. Okay, how about departure? Okay, we still are waiting for customer 1 to be departing the system lah. So departure, the next departure is customer 1 at time 4. Okay, this remain the same. So our statistic again remain 0. Okay, nothing to update here. Okay, at time 2. Now right now is at time 1. So how do we advance to the next time? So we check the future event list here. Which will occur first? Okay, arrival or departure? Okay, departure happen at time 4, arrival occur at time 2. So the next event will be at time 2. Okay, time 2 we're gonna have arrival of customer 3. So now customer 3 arrive here. So we have customer 3 and customer 2 waiting in the queue. Okay, waiting in the queue. So this is number of customer in the queue. Customer 3 and customer 2 because customer 1 is still at the server. Okay, so server is still busy lah. Okay, with one customer. Okay, who are at the checkout line now? Okay, so at the counter and also at the queue line, waiting line. Customer 1, customer 2, and customer 3 who arrive at time 2. Okay, so then we need to update our future event list. Future event list here. Okay, right. So you can notice that the the events, the end time of the simulation is at 60 minutes kan, all remain the same. But the arrival and departure we have to update lah. Okay, for the so at time, so which one happened first? Which one happened first between arrival and departure? So we have checked lah our data kat sini. Okay, so here the next event is the departure of customer 1 at time 4. And also the arrival of customer 4 at time 8. So how do we know customer 4 arrive at time 8? Okay, so currently we are at time 2, right? So the next customer, customer 4, inter-arrival time is 6. Betul? Ni, customer 3 ni inter-arrival time 6, meaning the next customer, customer 4 will arrive at time 6, right? 6 minutes later. So 6 plus 2 lah. Okay. Ni inter-arrival time between customer 3 and 4 is 6. So customer 3 arrive at time 2, right? So plus 6. So customer 8 arrive at time, customer 4 arrive at time 8. Okay. Customer 3 arrive at time 2. Okay. Because the inter-arrival time is 6 minutes. So 2 plus 6, customer 4 will arrive at time 8. So that's why we know customer 4 gonna arrive at time 8. So that's gonna be our next arrival. Okay. Okay, so still our statistic will remain the same, 0. Okay. Now, let's move next. So among these 3 events in future event list, which one will occur first? Okay, the departure of customer 1 at time 4 kan. So we move to time 4. Okay. So you can see now we skip time 3 kan. We skip time 3 because there's nothing happen at time 3. Okay. So at time 4 we have departure of customer 1. So what happened to number of customer in queue? It will reduce to 1. See? It will reduce to 1 because now customer 1 leave the system, customer 2 go to the server. Right? Customers 2 go to the server, customer 3 lah remain kat sini customer 3. Customers 2 kat sini. Sebelum ni customer 1 kat server, now customer 2 at the server. So number of customer being served is customer 2. Okay. One customer lah. Okay. So at the checkout line, who will remain at the checkout line? Of course lah, customer 2 and customer 3. Customer 1 already left the system. Okay. The next future event list. Okay. We're gonna have arrival and departure. Okay. The next arrival will be customer 5, right? Customer 5. So let's see. Actually, because at this point we haven't the customer 4 haven't arrived yet, at time 4. So we're gonna keep the event notice of arrival for the customer 4. Okay, ni kita keep dia sama dengan atas kan, sebab customer 4 ni masih belum sampai lagi. Okay, tapi departure we gonna have a new departure. Sebab tadi customer 1 dah depart, so who will depart next? Of course lah customer 2 kan. Customer 2 dekat cashier. So when will customer 2 depart? Ni kat time 6. How do we know? At time 6 because service time of customer 2 is 2. Okay, this is the service time of customer 2. So right now is at time 4 kan? Time 4. Right now is time 4. So 4 plus 2, 8, 6. So customer 2 will depart at time 6. That's why we have 6 here. Okay. Okay. Now you can see that now our statistic has changed. Okay, we are updating our statistic right now. Okay, S is what is S? Siapa ingat S? The sum of the waiting, the time spent, okay, the time spent of the customer in the system kan. Okay, why do we update now? Because customer 1 already left the system at time 4. So meaning that we already know how long customer 1 has spent in the system, which is 4 minutes lah. Okay, sebab apa 4 minutes? Because Customer 1 arrive first, terus go to the cashier and receive service time 4 minutes. So meaning customer 1 ni customer 1. Customer 1 4 minutes. Okay. Okay. Number of customer. Ini apa ND tadi? Total number of departures up to the current simulation time. Okay. Total number of departure now baru 1 lah. Okay. Baru 1. This is customer 1 only. Depart. Okay. So number of customer depart the system only 1. Okay. F. What is F? The total number of customers who spend 5 or more. Okay. At the checkout counter. Okay. So maknanya at this point 0 lah. Okay. No customer yet spend more than 5 minutes. Only customer 1 only spend 4 minutes. Okay. So we move to the next event, which is the next event will occur the earliest is at time 6. So we move forward at time 6. We skip time 5. Okay. Because nothing happened at time 5. So as we move to time 6, we update lah all this information. Okay. Now, at time 6, we have departure. We don't have arrival, but we have departure. So meaning that currently, people, before this, at time 4, only 1 customer in the queue. Okay, so when customer 2 depart the system, customer 3 go to the cashier, so there is no one lah. Okay, no one at the queue. So 0 lah, 0 customer in the queue. Okay, so who are being served right now? Customer 3. Customer 2 leave the system. So at the checkout line, we can see that only customer 3. Okay, customer 3 which arrive at time 2. So next future event is we're gonna have arrival. Are we going to have a new arrival? Okay, customer 4. So right now customer 3 right being served. What happened to customer 4? Customer 4 has not arrived yet. Okay, so we remain lah. Arrival is at time 8. Next arrival is at time 8 of customer 4. Okay, how about departure? Because at time 4, customer 2 depart. So we're gonna have new departure here. Okay, new departure which is now customer 3. Okay, the next event is the next departure is customer 3 who will depart at time 11. So how do we know at time 11? Let's see. Customer 3 takes 5 minutes. 5 minutes. So it customer 3 receive the service at time 4 kan? Okay. Betul? No. At time 6, right? Time 6 customer 3 receive here kan? Time 6 tadi customer 2 depart. So customer 3 receive the service. So at time 6 lah. 6 Customer 3 ni tadi. 6 restart the service plus 5 minute. Okay, so sama dengan 11. So that's why we have customer 3 gonna depart the system at time 11 here. Okay, what about the statistic here? Okay, because of what happened at time 6 is departure of customer 2. So we can calculate lah how long customer 2 spend in the system. How long customer 2 spend in the system? Okay, so customer 2 depart at time 6, right? And receive the when did the customer when did the customer 2 arrive, right? Okay, yes, because we want to calculate the time spent in the system, which is from the arrival and the exit of the system. So customer 2 depart at time 6 but arrive at time customer 2 arrive at time 1 kan? Okay, so 6 minus 1 become 5, right? So 4 tadi 4 kan? Plus 5. Okay, we get 9. We get 9. Okay, 5 minutes customer to spend in the system. Okay, so total up jadi 9 lah. Okay, and number of customer, apa tadi ND ni? Saya pun lupa dah. Departure, total number of departure 2 lah. Okay, customer 1 and customer 2. Okay, ni customer 1 and customer 2, 2. Okay. F. F is total number of customers spend more than 5 times. Okay, 5 minutes or more. Okay, because we know customer 2 now spend 5 minutes. Okay, customer 2 spend 5 minutes in the system, so we can update lah F to be 1. 1 ni come from customer number 2. Okay. Okay, F ni adalah total number of customer who spend 5 minutes or more at the checkout counter. Okay, so that's why this become 1. Okay, because we have one customer spending 5 minutes here. So we can move forward lah to the next. Okay, until all the customer lah. We have all the customer here. Okay. Sebenarnya banyak lagi ni, tapi kat sini example here only demonstrate up to customer number 7. Sampai kat sini saja. So the rest tu mungkin you boleh buat sendirilah. Okay. So make sure lah you faham macam mana this is being developed. How this is being developed. So basically kalau dalam simulation software, dia akan structure the simulation tu based on something like this lah, macam simulation table like this. Okay, okay, you must keep track of the clock time, okay, system state, okay, future event list, okay, as you move from time to time, okay, what's going to happen in the future, okay, and the statistic you collected, because you want the average over time. Okay, so that's why you calculate collect the statistic from time to time. Okay, so at the end, okay, our goal is to get the average response time, the average time customer spend in the system at the checkout counter tu. So we gonna divide. Okay, because simulation time tadi yang kita show tadi kat the previous table is 23 minutes only. So we can divide lah. S ni summation of all customer time in the system divided by number of customer that have depart the system, which is 6 at this point. Okay, up to 23 minutes tadi only 6 customer depart the system. So we divided by 6. Okay, this time 35 tadi ni. Okay, ni 35 ni. Number of customers that have depart the system so far is 6. So we divide the two numbers. Okay, so we get 5.83 minutes. The observed proportion of customers who spend 5 or more minutes in the system was F divided by ND lah. Okay, proportion of customers spend more than 5 minutes or 5 minutes or more. Okay, so we divided the number with the number of total customer that has departed the system. Okay, so maknanya 83% of the customers spend more than 5 times. So that's, let's say if your goal is to make customers spend less than 5 times, less than 5 minutes. So meaning that 83% of the customers spend more than 5 minutes. Okay, meaning that you have to do something lah with your system. Okay, to you make it reduce to less than 5. Okay, because majority spend more than 5 minutes. Okay, so that's all. The next one is the simulation software. These are an example of other simulation software that you can explore lah to see how they differ from the Technomatics, the one that we use in this class. Okay, sebenarnya banyak lagi list ni. Tapi ini sebahagian sahaja ada macam-macam lagi sebenarnya ini yang software yang boleh simulate discrete event simulation. Okay, so as your homework for this week, you need to choose any system. Okay, And describe the entities, attributes, activities, events, and state variable of the system. And you have to give at least 2 examples of each category and submit your response on YouLearn. Okay. Alright. So an example is macam yang ni lah. Okay. Yang previously. Like this one. You have to do something like this one lah. Okay. Ada system, state, entities, event, activities. Okay. Tengok apa yang saya minta tu. Okay. Alright. That's all. So our next lesson will be statistical models in simulation. Okay. Thank you.